B. Forrest asks, so I'm learning about particle sizes and I see that smoke particles are just a wee bit bigger than COVID virus particles. So how come we can see smoke? Is it because there's a lot of it? This is a great question and it covers a few areas. First, when you say smoke, it's not exactly clear what you mean. There are many different types of smoke or sources for smoke that people commonly experience. So things like cigarette smoke, campfire smoke, car exhaust. Now, since you're comparing smoke with aerosolized virus, let's assume that you're talking about cigarette smoke. So why do you see cigarette smoke and not exhaled aerosol? Now, some of you may be thinking in cold weather you do see exhaled aerosol. Here's the thing. While this is aerosol, it's not exhaled aerosol. Meaning, it's not aerosol that is formed in the body during inhalation that is then exhaled. It's actually water vapor that is condensed out of the air once the warm exhaled air is rapidly cooled. You may not realize this, but you have seen this countless times in your life when you look up. As warm, moist air rises, it's cooled, and this causes the water vapor in the air to crash out and form water droplets, resulting in cloud formation. This happens because warm air can hold more water than cold air. Now, people have used this general lack of knowledge to produce videos like this to suggest that masks don't work. Again, this is aerosol, but it is not exhaled aerosol. It's condensed water vapor. And pathogens are not exhaled on water vapor because water vapor is a gas. Videos or memes that argue masks are ineffective because water vapor passes through them do not seem to understand the difference between an aerosol and a gas. One can contain a microbe, and the other can physically not. All right, getting back to the original question. Why do we see smoke but not exhaled aerosol? Now, to answer that, we need to know what determines if we can see any aerosol. There are three main factors that determine the visibility of aerosol. One is size, so the size of the individual particles. Two is the number of particles in a given volume, so the concentration of the particles. And three is the refractive index of the aerosol, essentially how well each particle scatters light. The more it can scatter, the darker it is. All right, so let's walk through these one at a time, starting with particle size. So shown here is a log scale. Now for context, protein molecules are typically under 10 nanometers in size. Viruses such as SARS-CoV-2 are around 50 to 120 nanometers in size. A spider strand is a few microns wide, and a human hair is roughly 100 microns wide. So cigarette smoke has an average size of under about a half a micron, while exhaled aerosol is slightly larger, but not by that much. So, in terms of visibility, aerosol size is not a reason why you can see one and not the other. So, what were the other reasons? Are the number of droplets different? Well, in terms of particle number, the amount of particle that is exhaled is very low and thus very hard to detect. Thus, extraordinary efforts are taken to be able to measure the amount of exhaled aerosol. The number of particles exhaled is on the level of about 1 per centimeter cubed. And since people exhale about a half liter per breath, this means that in a single exhalation, less than 1,000 individual particles will be exhaled. Now, when you compare that to the number of particles in cigarette smoke, the difference is stark. There's literally more than 1 billion times more particles in cigarette smoke than exhaled air. So while the size of the aerosol types aren't that different, the number concentration is very different. Finally, there's the ability for particles to scatter light differently. The refractive index describes the degree to which light is bent when it passes through a material. It's a relative scale, where the air has a relative index of 1, and pure water has a relative index of 1.333. Respiratory fluid is largely made up of water and soluble salts and proteins, and as a result, its refractive index is very similar to that of water. Cigarette smoke is a byproduct of combustion, thus contains materials such as soot. As a result, the refractive index is higher, reaching around 1.5. Now, for context, that's near the value of olive oil, but not as high as diesel soot. So, when taken together, the reason why exhaled aerosol and cigarette smoke look so different is largely due to the differences in particle numbers and to a minor degree the refractive index.